Let us understand how do we find derivative using first principle. In this video, we have taken 4 important examples which will be foundation for you to understand the complete concept. We will also find the derivative at a given point and see its geometrical significance. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss how do we find the derivative of a function using quotient concept, difference quotient concept. This is also called the first principle for finding the derivative. In fact, it provides the definition of derivative itself. Perfect. The question here is, find derivative of the following functions from first principle. Then find the value of the derivative at indicated x value, that is f prime x. 4 questions are there for you. First one is quadratic function f of x equals to x square minus x, and then you find derivative at origin. Second, f of x equals to square root of x plus 1. Derive the general expression using the first principle and then find the derivative at x equals to 8. Question 3, cubic equation f of x equals to x cubed plus 1 and then find derivative at minus 1. And question 4 is a rational or reciprocal function 10 over x, then find derivative at x equals to 1. So from derivative definition, we get this formula, right, which is actually called difference quotient. Limit h approaches 0 for f of x plus h minus f of x over h. So this actually gives you gradient of a tangent, right? So as h approaches 0, the secant becomes a tangent, and so that slope becomes the slope of the tangent itself. And therefore, this function gives us the derivative. And using this function to find the derivative is called derivative using first principle, correct? So that is the concept which you have to use. I hope the concept is absolutely clear. I'd like you to pause the video, answer these questions, and then look into my suggestions. Well, in case you want to learn from me directly, you can always send an email on the address given. Most of my students are doing extremely well. Some are there right on top of their class getting awards and scholarships.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
Now, let us see how do we use this difference quotient method to find the derivatives. Let's begin with the very first question, which is f of x equals to x squared plus minus x. So, if you're given f of x, I would like you to write down what is f of x plus h. Well, f of x plus h will be replace x with x plus h, right? So that is what you get, right? I would like you to simplify this, expand and simplify. So x plus h whole square will be x square plus 2xh plus h square, right? And here we have minus x minus h, right? Let's simplify it further, which you cannot, right? So because x square, all these are different terms, perfect? So we'll leave it right there. Now f of x is already given to us. Now, when I say find derivative using first principle, then it really means that we have to find or simplify this particular expression. Limit h approaches 0 for f of x plus h minus f of x over h, correct? So we have found what is f of x plus h, which is all this. Normally, I'll just straight away write this in the formula and do it for the next examples. But here, let's try to understand it in more details. So f of x plus h is all this, which I'm going to write down here now, which is x squared plus 2xh plus h squared minus x minus h, right? So this is the first part. Okay, I have to write limit h approaches 0 also before this. So limit h approaches 0 and all this, which is x squared plus 2xh plus h squared minus x minus h, correct? And then minus of f of x. F of x is the function given to you. So you say minus of x squared minus x, correct? Everything divided by h. So from here, what do you notice? From here, you notice that x squared cancels with x squared and minus x also cancels with this minus x because we are subtracting this. And therefore, we are remaining with these three terms in the numerator. And these three terms in the numerator are 2xh plus h squared minus h, right, over h. Now we can take h common in the numerator and rewrite this expression as limit h approaches 0, h common, 2x plus h minus 1 over h. So at this stage, you can cancel h. Once you have cancelled h, you can substitute h equals to 0 in the given expression. And therefore, what do you get here is, this becomes 0, right? You left with 2x minus 1. And that means that the derivative of this function is 2x minus 1. You get the idea. So we have this derivative. So we can write down here that the derivative of the function is equal to 2x minus 1. Perfect. So we have done the first part. Now the second part is to find the derivative when x is 0. So to find the derivative when x is 0, we'll substitute 0 for x and then evaluate. So let's do the second part now, which is, what is the derivative when x is equal to 0? Substitute 0 for x, you get 2 times 0 minus 1, which is minus 1. So the derivative or slope of the gradient or tangent at x equals to 0, the origin, is minus 1. You get the idea, right? So it makes sense because if you sketch this particular graph, what do you get? Well, you get a parabola, right? Let me sketch and show you. You get a parabola for sure. X, if you take common, x minus 1 gives you two roots, one at 0, one at 1. Like this, right? And you notice here very clearly that the slope of the tangent at this point origin is this. And that is what we are saying is the derivative at 0, which is minus 1. So that is the geometrical significance of what we just done. So I hope with this you understand not only how do we find the derivative using first principle, but also its geometrical significance, right? So this is very important to understand. That's the basics of calculus, right? So calculus, difference quotient concept, I hope it is absolutely clear. Perfect. Let's move on and take the next question now. So the next question is, f of x equals to square root of x plus 1, and we need to then find the derivative when x is 8. So using the definition, what do we get? Well, the derivative of this function is limit h approaches 0 of f of x plus h minus f of x divided by h, right? Which is limit h approaches 0. F of x plus h means replace x with x plus h. So you get within square root x plus h plus 1 minus f of x, which is square root of x plus 1, correct? Over 1 h. So that is f of x plus h minus f of x over h. You see that? Replace x with x plus h to find f of x plus h. Now we need to simplify this. How do you simplify this? So you learn the technique of rationalization, right? So adopt the technique of rationalization. Correct? You have to rationalize numerator. That means multiply and divide by the conjugate of numerator, correct? So let's continue. We get this function derivative as equal to limit h approaches 0, numerator being square root x plus h plus 1 minus square root x plus 1 over h. We'll now multiply and divide by the conjugate, which is square root x plus h plus 1 plus square root x plus 1, clear? And also divide by the same term, which is square root x plus h plus 1 plus square root x plus 1. So when you do so, in the numerator, you get a square minus b square. That is, I can write this as limit h approaches 0. Square of these means x plus h plus 1 minus square of that means x plus 1, right? The square root goes away. And in the denominator, we have h times all this, right? Which is square root of x plus h plus 1 plus square root of x plus 1, correct? Now in the numerator, you can simplify x plus 1 and x plus 1 cancel, correct? You're left only with h. So we can rewrite this as the derivative becomes limit h approaches 0 and we have only h in the numerator and the denominator is h times square root x plus h plus 1 plus square root x plus 1, correct? Now you can cancel h and substitute the limit h approaches 0. You can do so now because the term which was giving 0 in the denominator has now vanished. It has got cancelled out, right? So when you do that, you get what? Putting 0 for h, we get 1 over. So I'm not writing limit now. Do you see that? Because I'm substituting the value of h as 0. Square root of x plus 1 plus square root of x plus 1, correct? So now we have an expression for the derivative of the given function, right? This is a general expression, 1 over 2 square root of x plus 1. So that becomes the derivative for this function, right? You get the idea. Now we need to find what is the derivative at x equals to 8. So substitute 8 here to find the answer. Perfect. Then what do you get? So let's do it. I got very limited space, so I'll just finish it off here. So derivative when x is equal to 8 will be equal to 1 over, we are replacing x with 8, right? So 2 over square root 8 plus 1, correct? Which is 9. So I'll rewrite here 1 over 2 times square root of 9 and which is 3, right? So we get 1 over 6. So this value is equal to 1 over 6. You see that? So let me highlight this. We have very limited space. I just squeezed it in, but I hope it makes sense, correct? That is part B. Finding the value at the given point x equals to 8. Clear? Now, let's take the next example with question number 3. I hope the concept is clear, right? In case you want to learn from me directly, you can always send an email on this particular address. So here is the third question, which is find the derivative using first principle, which you fairly well know now. And we know the formula for that is limit h approaches 0, f of x plus h minus f of x over h. Now in this function, we have x cubed plus 1. Difficulty with some students will be, how do you do x plus h whole cube, right? So you need to know the formula for a plus b whole cube, right? So let me give you the formula for a plus b whole cube also. So if I have a plus b whole cube, what is this equal to? A cube plus 3 a square b plus 3 ab square plus b cube, correct? You can also find this formula using Pascal's triangle, correct? Because many times in the test, you may get this power as not just 3, but 4 or 5, right? Okay, so that becomes your a plus b whole cube. So let me write down the limit of this function as limit h approaches 0. And in the numerator, we are going to use this particular formula, difference quotient formula. F of x plus h will be x plus h whole cube plus 1. So this is the first part, right? Minus f of x means minus of whatever is given to us as the function. Perfect. Divided by h. So we can expand using the given formula, which you know now, which gives you x cube plus 3 x square h plus 3 x h square plus h cube. And then we have plus 1 here minus x cube plus 1, correct? And the denominator being h. Always you will find that every term which do not include h cancels. So x cube cancels with x cube, 1 cancels with 1. Do you see that? Always. And from the remaining, you can factor out h. So I'm going to write the derivative of this function as equal to limit h approaches 0. And I'm taking h common directly now, right? So h common. 3x square. Second term means 3xh. And the third term being h square, right? Divided by h. So as I was saying, and as you have observed in previous two examples, h will cancel at this stage. So you have a simplified expression where you could substitute h equals to 0. So now let's substitute h equals to 0, which will cancel out these terms. Do you see that? And what you will remain with is 3x square, correct? So once you do that, you get, so I'll write down this as 3x square. So the derivative is 3x square, perfect, because the other terms are 0 when we substitute h equals to 0. So we can write down that the derivative of this function is 3x square, correct? So that's the first part. Now the second part of the question is to find the derivative at x equals to minus 1. So let me do it in this corner. Okay, so I'll use different ink. So when we say derivative at minus 1, we really mean substitute x as minus 1. 3 times minus 1 whole square. And that gives you 3 times 1, which is 3. Correct? You get the idea. So it is positive 3. Perfect. And if you sketch this graph, you will notice that it will make sense to you. Cubic functions are kind of like this, right? So I'm just sketching here a graph to help you visualize the situation, right? So Okay. So at minus 1, you get this 0, right? Okay. So what we are saying, at 3, the derivative will be at x equals to minus 1. So if I put minus 1 here, you do get a 0, right? So at minus 1, the slope is 3. This is what we are saying. So we say gradient or m equals to 3 of this tangent at minus 1. You get the idea, which happens to be the x-intercept for this particular function. Perfect? Okay? So I hope while doing all this, because this is the foundation for you, understand the key concepts, okay? Let's move on and take up the last question, which is 10 over x, a reciprocal function, right? So the derivative for this function will be what? Derivative will be limit h approaches 0. So we have 10 over x plus h minus 10 over x, correct? Since the formula you remember is limit h approaches 0, f of x plus h minus f of x over h, right? So we have applied the formula. So over h, I'm writing like everything divided by h, like multiplying by this. Okay, is that okay? So now, to solve this expression, what we could do is we can take a common denominator and cross multiply, right? So that will be easy way of sorting it out. But before that, let me rewrite this expression as limit h approaches 0. We're taking 10 common, right? And h is already common. So I'm writing 10 over h here. Right? Is that okay? And we have 1 over x plus h minus 1 over x. Is it okay? So we took 10 common. H is already outside. So let me change the ink here. It's better because things get mixed up, right? So when you're working with limited spaces, you have to use different colors. So we have limit h approaches 0, 10 over h, and within brackets, I'll cross multiply. So we get x minus x plus h. See the importance of the brackets which I'm putting, right? And the denominator will be x plus h times x. Absolutely clear? We take common denominator, cross multiply. So we have limit h approaches 0, 10 over h. And here, x minus x is 0, but we get minus h here. Is that clear? In the numerator. And the denominator, we have x plus h times x. Now you can cancel these, right? Since you have cancelled, you can substitute this limit and that becomes 0, correct? So we can rewrite this function derivative as 10 minus sign is here, right? So remember that over we have x plus 0 times x. Do you see that? So we get this derivative of the function as minus 10 over x times x, which is x squared. You see that? So that becomes the derivative of the function. Very important. Now let's do part B, which is find the derivative at x equals to 1. So let's substitute 1 there for x. So the derivative of 1 will be minus 10 over minus 1, 1 square. So which is minus 10. So the derivative is negative 10. Does it make sense to you? Let's say, let me sketch the graph and then show you. What does it geometrically signify? So I've added this part purposely so that you get a full picture of this, right? So the graph of 1 over x or 10 over x will be something like this, right? When we are saying derivative at 1, so it really means the tangent which goes like this here. You see that? And the gradient of this tangent m is negative 10. That is the meaning of derivative at 1 is minus 10. You see that they are linked. And the point here is at x equals to 1. Correct. So that's the meaning. So I hope with this you have understood the complete concept, right? So we did actually all the 4 questions for you. So if you see, we started with the parabola, which is x square minus x, did the first principle, and we got this answer as 2x minus 1. Once you get this derivative, to find the value at a given point, substitute that point, the x value, and get your answer. Correct? So in this case, we got our answer as minus 1, which signifies a tangent with gradient or slope of minus 1 as shown here. Perfect. At a point which was 0 at the origin. The next example, which we took of the square root function, there we found gradient at 8, right? So this square root function, if I sketch it, it will look like what? So let me just sketch it here in this corner. Since it is square root x plus 1, it actually moves left and then it's kind of like this, right? That is the graph of this function. And derivative at 8, which we got as 1 over 6, right, a small value, is basically, we could have had a tangent here at 8, right? So this is the tangent. That is the point x equals to 8. You get the idea, right? 8. And the slope of this is 1 over 6. So we are talking that is the slope of the tangent. Is that clear to you? So sketching a graph and visualizing is another very important part. When you are doing cubic function, as I sketched here, the cubic function, minus 1 is its x-intercept. And at x-intercept, we found that the slope was 3. And in the last question, where it was a reciprocal function, we found that the slope is negative 10, right? After deriving the formula for the derivative using first principle. Perfect. So I hope with this the concept is absolutely clear. Feel free to write your comments and suggestions. In case you like and subscribe to my videos, that would be great. And in case you want to learn from me directly, you can always send an email on this particular address. Thanks for your time and all the best.